Myself Shankar Karmakar, Assistant Professor, Department of IT. Today I am going to discuss about the multiplexer, digital electronics. The first question, what is the multiplexer? So first, the multiplexer is a digital circuit, digital combinational circuit that has the multiple input and a single output. And the multiple input, there is the two type of input. One is the select input, another is the data input. So select input is as this is the select input that data input that will be derived by the select input. That is why this is called the data selector also. It has n number of data input, that the multiple input, and once there is only one single output, and there is the m number of, if there is the m number of select input, then the select data input will be depend on the select input, that is 2 to the power m is equal to n. That is the n is the number of data input, that n is equal to 2 to the power m, that is the data input. So next, this is the block diagram of the n:1 multiplexer. Why n? N is the number of data input. This is the D0, D1, D2, D3 up to Dn minus 1. As this is start from 0, that is why n minus 1, Dn minus 1. That the data input is this. And next, that is the select input. That select input is defined as the S0, S1, S2, S3 up to Sn minus 1, n number of select input. So that is why this is called the n:1 multiplexer, and there is 1:1 output. So this is the block diagram. So what is the type of multiplexer? As there are four type of multiplexer is there. 2:1 multiplexer, that is there is the only one select input, and there is the number of data input is 2 and only one output. 4:1 multiplexer. So this 4:1, these are the type of the multiplexer. 4:1 multiplexer is what? There are 4 number of data input and 2 number of select input and only one output. Similarly, 8:1 multiplexer and 16:1 multiplexer. So the 8:1 multiplexer having 3 select input and 16:1 multiplexer having 4 select input. The select input is at 4. So data input is given. We will get the data input as 2 to the power 4 is equal to 16. That is the 16:1 multiplexer. Next, so 2:1 multiplexer, already we know 2:1 multiplexer having 2 data input, only one output, and one is the select input. If the select input is, we just take S, so the number of only one variable, that if we write this binary 0 or 1, so we will get 0 and 1, and data input is 0, D0 and D1. That is why D0, D1 is the 2 data input, only one select input, and this is the enable input. Enable, that is the power supply VCC 5 volt, and that only one output. This is the block diagram of 2:1 multiplexer. Similarly, 4:1 multiplexer. This 4:1 multiplexer having the select input is S0, S1. This is the S0, S1. This is the select input, and we will get the output Y. That Y is equal to D0, D1, because this select input S0, S1 will be derived the data input D0, D1, D2, D3, and we will get the output Y. So the combination of two data select input S0, S1, 2 to the power 2, that means 4. The 4 number of variation can be possible with two select input, that 0, 0, 0, 1, 1, 0, 1, 1. This is the truth table of the 4:1 multiplexer, and we will get D0, D1, D2, D3. These are the output. So if we get the output Y with the logical expression will get the output Y. We can implement this with the logic gate, basic logic gate like AND gate and OR gate and NOT gate. So this Y is equal to, that means according to the this truth table, as this is the H0 and H1 is when both are 0, we will get the output D0. That means in the sum of product, this will be like that. Sum of product, we will get this one, that sum of product, that S0 is equal to S0 and S1. These are the two input. So this 0, 0, next 0, 1, 1, 0, and 1, 1. So So these are the input and corresponding output will be y. What y is equal to? Y is equal to like that d0, d1, d2, and d3. So we will get the sum of product that y is 0. That actual the y is equal to what? We can write this y is equal to we can write it that s is equal to 0, s1 is equal to also 0. That is why s0 complement, s1 complement, and d0. This is the one part. Next, again we can write also h0 complement, s1 and d1. So similarly, next term will be that s1 bar, h0 and d1. So next term will be there, and we will get this. So these are the this truth table. This expression will be get from the truth table of the 4:1 multiplexer. And next, this is the we will get the output, total output. This y is equal to what? S bar, S1 bar, H0 bar, D0 plus S1, H0 bar, S1 bar, H0 D1, H1, H0 bar, D2 and H1, H0 D3. These are the input, and we will get the implement the basic logic gate. That the 4:1 multiplexer. So similarly, we can also drive the 2:1 multiplexer, 4:1, 8:1 multiplexer, 16:1 multiplexer. These are the basic block diagram. That the basic block diagram what we have seen in before, but in the behind of the block diagram, the circuit is that the AND gate, 4 AND gate, that and 1 OR gate and 2 NOR gate. Next is the use of multiplexer. So we can use this multiplexer in where? In data communication, several computer to communicate over one line. Then there is the one line, that output is one, but there is the multiple input line, that is the data line, and that select line. That select line will be drive the multiple data line, but at a time one line will be selected and we will get the output. And next some radio station like that radio to select the channel from main. There is lot of radio station frequency, and we will select one and we will get the output. That means song or play something another program we will get. Next is the route the data within a computer. That means router is there that routes the data within a computer, and we use the function generation using the multiplexer. Next, suppose this is the application of the multiplexer. Where do we application? There are the multiple sources are there. That is the MP player, then laptop, source card, digital satellite, digital cable TV. These all are the source. Multiple sources are there, and this multiple source will be connected to the data input line, and that will be derived by the select input A and B. That is the two select input A and B. That suppose when A is equal to 0, B is equal to 0, B is equal to 0. That's the select source. Multiple source are that source is MP3. That means when A and B both are two input are 0. That MP3 will be connected to the data input line D0. Similarly, laptop, that 01 for satellite, 10 for TV cable, that is 11. So this data input will be connected to the select input. That means the select input will be derived which source will be connected to the data line, and we will get the sound system. That means you will get the sound. We will listen the sound, but which source will be connected to the data input, and who will be selected for this one, and that will be derived by the select input, and we will get the sound system. So there are that the multiplexer is selector and signal destination. So next is suppose there is a that multiplexer having 4:1, 8:1, 3:1, and 4:1, 2:1, 16:1 multiplexer, and this multiplexer what is the function is given x f of x y z is equal to summation of m 1 2 4 7. This is the value of the function. This is the given function is 1 2 4 7. So this function can be implemented with the 4:1 multiplexer. Actually, there are the three variables. So three variable, the three select input. Actually, when we get this three select input in a multiplexer, that is for 8:1 multiplexer, because in 8:1 there is the 3 select input. So that means the number from 0 to 7 that will be written as the function, that any number from 0 to 7 will be written in a function, and we can implement this 8:1 multiplexer into 4:1 multiplexer. In that case we have to take like that. Suppose the functional value is what 1247. So just like that, 1247 is the function value. So we just write here 0, 1, 2, 3, 4, 5, 6, and 7. This is the decimal value, and the functional value is that the functional value we just take H0. We just take that the H0 that is the S0 and S1. Okay, this is the H0 and S1. So this H0 S1 we just write 0 0 0 1 0 1 2 1 0 3 1 1 4. So 3 H0 S1 H0 S1 and S2 will be there. Then the another function like see that is the H0 S1 and S2. H0 S1 S2, that is the 0 0 0 0 0 1 1 0 1 0, and like that we will get the 1 1 1 7. So this function, when we are implement this function, that the H0 S1 we just take here A, B, and C, like that. A, B, C. Three input are there for the select input. So one of the input, that the select input C, that will be goes to the data input, and the complemented, that means the value 8:1 to 4:1 multiplexer we are forming. So that is the in 8:1 the input data input is 8. That will be converted into 4, because we are going to convert this 4:1 multiplexer. So we just take this function 1 2 4 7. That values will be just take as a C variable. C variable, that's ABC, which is converted to this, and we will get the function is that this is the 4:1 multiplexer. This 4:1 multiplexer, that means that I0, I1, I2, and I3, like that, and we will get C complement and C. Okay, C complement and C, and the values 0, 1, 2, 3, 4, 5, 6, 7. And in the function given value is what? 1 to 4 7. That is the 1, 2, 4, and 7. So these are the given function in our given values in our function. So where this is the circle A is given, so that is actually lies in C. That we just take the C. Again 2 is lies in the complement of C. So we just take a complement of C. Again 4, which is complement of C, and 7, which is the values of C. That means this I0, I1, I2, I3, 4 data input, that data input will be connected. That I0, I1, I2, I3, 4 data input, that will be connected. I0 and I3, which is connected to C. Here just instead of C, we just take as J. Just we just take the variable as J name. Name of the variable is J. We just take here, but we just I just define here the variable is C. So we just take C, that I0 and I0 and I3, which is connected to J, that means C, and I1 and I2, that is connected to the complement value of the C bar, that means the C. So these are the J, which is given here C, and that I0 I3, that will be connected to C, and I2 I1, that will be connected to complement variable of C. So we can convert this 8:1 multiplexer to 4:1 multiplexer, and similar way we can convert the 8:1 to 16:1 to 8:1 and continue. So this is the conversion, implementing the function, that means multiplexer from any function can be complemented higher multiplexer to lower multiplexer. And thank you.